Today we will be learning how to integrate by parts. Now this is another tool that we will be adding to our integration toolkit. We will be deriving this by first taking a look at the product rule in differentiation. So let's have two functions here. Our first function, u of x, and we're going to multiply it by our second function, v of x. Now remember, if we differentiate this with respect to x, then what we're going to get from our product rule of differentiation is u prime times v plus u times v prime. So now if we integrate both sides, what we're going to get on the left-hand side is just our original functions, but in their most general term. So we're going to have a plus c here. And on the right-hand side, we have the integral of our result here on the right-hand side. So u prime v plus u v prime. The integral is with respect to x. Now, if we isolate this second term on the right-hand side here, then what we are going to get is the integral of u of x, v prime of x dx is going to be equal to u of x, v of x, minus the integral of u prime of x, v of x, dx. Now, this is just reverse product rule isolated for the integral of u times v prime dx. So, right now we have the formula for integration by parts. If we have a function u of x times v prime of x, we can express it in terms of u of x times v of x minus the integral of u prime of x v of x. So how would this be useful? Well, this would be useful if this second integral over here is easier to compute than this first integral. And when we're doing integration by parts, more often than not, you'll see v prime of x dx be represented by dv. So instead of seeing this, what you're going to see is dv, and that's going to be equal to v prime of x, v prime of x dx, and du is going to, more often than not, replace u prime of x dx. So your integration by parts formula, usually it's going to be written in this form. The integral of u dv equals u times v minus the integral of v du. Now this is exactly the same as this formula that we wrote in this third line over here. It's just simplified with dv and du. So right now, let's take a look at an example where integration by parts is useful. So if we want to integrate the function x cosine x dx, and if you take a look at this, you'll see it's the product of two functions. So you might consider integration by parts, since it is indeed reverse product rule. And if you think of trying to use substitution, well, cosine x and x are both different functions. If you take the derivative of any one of them, you're not going to end up with anything similar to the other function. So we can't really substitute any variables. So we must use integration by parts. Now the question is, which function to differentiate? Do you want to set u equal to x or cosine x? Well, usually in integration by parts, you want to try to get rid of a term. So more often than not, you will try to differentiate the more simple function, the function which will eventually decrease in powers. Now, if this doesn't work, you can always try to differentiate the other function. But right now, we'll just give it a try. We'll let u equals x. So du over dx is going to equal 1. Or another way of writing it is du equals dx. So what we've done is just we've moved this dx over to the other side. And if u equals x, then what is going to be our dv? Well, if u equals x, then this is going to be our dv. So if we write that, it's going to be dv equals cosine x dx. Now notice how in integration by parts and integration by substitution, when you take the derivative of something, you tend to not write it in this form. You tend to write it in this form, where you have your du's and your dx's on opposite sides. So let's take a look at our dv. Well, what is v going to be? Well, v is just going to be the integral of cos x. Well, that's just going to be sine x. Now, if you recall our formula that we derived earlier, u dv is going to be equal to uv minus the integral of v du. So, if we go back to our example, then we can rewrite this integral as u times v. So u is x and v is sine x. So it's going to be x sine x minus v du. Well, v is sine x and du is just dx. So minus the integral of sine x dx. Well, we know this integral, and this integral is much easier than our original integral, so our integration by parts has indeed worked. So integral of negative sine x is just positive cosine x. So what we're going to get is our antiderivative is going to be x sine x plus cosine x plus c. And this is going to be our final answer.